Step ramp type. To better explain this state type, in addition to detail view window, signal view window is maximized too so you can view the outputs. In the signal view window, the signal view type is set on RMS mode. Digital signals are disabled, and to have a better view of the signals are turned bold. In this state type, it is possible to set the voltage and current outputs of the device to increasing or decreasing ramp. This state type is used when the user wishes to get a threshold for a parameter. It should be mentioned that it is possible to apply this ramp to amplitude, phase, and frequency, or a combination of these options for voltage and current signals. It should be noted that to better understand the concept of a step ramp, only general direct mode is explained. Creating a ramp output requires three values: start value, step value, and final value. Start value section. In this section, the start value of ramp is specified, and it indicates that from what point the ramp should start. These values can be specified for the three parameters of amplitude, phase, and frequency separately. These values can be specified for the three parameters of amplitude, phase, and frequency separately. Binary output, binary input, and other setting sections are explained in previous videos and will not be mentioned here. Step values section. In a step values section, the value for every step is specified. These values can be specified for the three parameters of amplitude, phase, and frequency separately. For example, the value of a step for voltage is set 1, 2, and 2 volts. Final values section. In this section, the final value of the ramp signal, and it indicates that at what point should the ramp finish. These values can be specified for the three parameters of amplitude, phase, and frequency separately. The final value of voltage in this section is 20, 25, and 30 volts. You can see that the signal of all three voltage phases has reached from the start value to the final value according to the specified steps in form of a ramp. In the time setting box, in a step ramp setting section, the time of each step is specified. This value is 500 milliseconds by default. By checking the Enable Reset option, it is possible to allow the signals to reset after a specific time period. In Reset Time section, the time of each reset step is specified, which is added to the state time. To set the value and its parameter, you should go to the bottom of the page in Reset Values section. This section and Disable Relay section has already been described in previous videos. There are two options in the ramp type section, where the first option, which is step values, is active by default. By selecting this option, the settings are as described before. As you can see, for example, in L1 phase, each step is increased by 1 volt every 500 milliseconds, but by selecting rate value per second, the number of steps specified in the step values table is determined as value per second. For example, L1 phase should increase by 1 volt every second. According to the specified step time, every second there will be 2 500 millivolts a step. In ramp description section, the steps of the ramp, the total time of the state, and the errors are described. By using the simple mode option, it is possible to specify the value of the steps of the ramp and the final value of the ramp more easily. By checking the simple mode option, the settings of step values and final values table are disabled, and a new section including voltage and current sections are opened. In these sections, first, the parameter is selected from the slider bar. The slider bar includes amplitude, phase, and frequency options. After selecting the parameter, two options are displayed. In the step value and final value fields, the step value of the ramp and the final value of the ramp are specified respectively. The difference between this option and the previous state is that in this state, all three phases change simultaneously. An important point in ramp on frequency is that there will be a signal jump. So it is possible that while testing the frequency relays, an appropriate response is not received from the relay. While ramping on a frequency to keep the signal steady, it is necessary to check the continuous in frequency step. By specifying 2 Hz as the start value of frequency and 3 Hz as the step ramp and 50 Hz as the final value, there will be a frequency jump in the output signal. To view this frequency jump, first the output signal must be set on inst. As you can see, by checking continuous in frequency step, this frequency jump disappears.